Working with sets. Objectives. 1. To write sets and identify subsets. 2. To find the complements of a set. Sets. Roster form is one way to write sets. An example would be the set of multiple of 2 as 2, 4, 6, 8, etc., etc. Set builder notation is another way to write sets. It describes the properties of an element must have to be included in the set. Example, the set of the multiple 2 as, and it's read, x such that x is a multiple of 2. Example 1. It says n is the set of even natural numbers that are less than or equal to 12. Okay, so our natural numbers, remember, are our counting numbers. So the roster form would be 2, 4, 6, 8, 10. And it says, notice it says less than or equal to, so we include 12 as well. Okay, and then in set builder notation, we would say n such that n is an even number, sorry, even, not event, even natural number less than or equal to 12. Example 2 says, in set builder notation, how would you write the solutions of 9 minus 4n is greater than 21? Okay, so I'm going to start off with 9 minus 4n is greater than 21. I'm going to subtract 9 from both sides because I'm trying to get n all by itself. So now I have negative 4n is greater than 12. I'm going to divide both sides by negative 4. And I get n. Now notice we divided by negative 4, so I'm going to flip the sign. N is less than negative 3. And so in set builder notation, I'm going to say n such that n is less than negative 3. The empty or null set is a set that contains no elements, represented by a circle with a line through it or brackets with nothing inside of it. Example 3, it says, what are the subsets of P when P is equal to A and B? Of the sets S where S is equal to A, B, and C. Okay, so subsets include any choice that we have here. So we'll call this A and we'll call this one B. Okay, so for part A, when I'm listing all the subsets of P, it could be the empty set. A subset would just be A, or it could just be B, or it could be A and B. Now, the subsets of S, because there's 3 elements, subsets of S could be, again, the empty set. It could just be A. It could just be B. It could just be C. It could be A and B. It could be A and C. It could be B and C. Or it could be A, B, and C. Notice those are all the different possibilities of arranging the numbers, or way of arranging the letters. Okay, in part B it says, let A equal x such that x is less than or equal to 3, and B equal x such that x is less than or equal to 0. Is A subset of B? Explain your reasoning. The answer is going to be yes, because if you think of your number line, it says for A, we'll do A in green. And it says x is less than or equal to negative 3. So I'm going to go over here to 0, 1, 2, 3. So I have negative 3. It says x is less than that. So I'm going to have an open circle at negative 3, and it's smaller than that. Okay, and then it says B is X is less than or equal to 0, so we're going to do B in blue. We have a closed circle at 0, and we're going this way. Notice that our A portion of our graph is included in the B portion, but not all of our A is included. A goes from here down, but B includes all of that. So B is a subset of A, but not vice versa, because there's this part right here that's only in B. So we can say yes, all elements of A are in B, because -3 is less than or equal to 0. Okay, when working with sets, you call the largest set you're using as the universal set, or universe. The complement of the set is the set of all elements in the universal set that are not in the set. You denote the complement of A by A prime. Example 4 says a universal set is months of the year, and A is the months with exactly 31 days. What is the complement of A? Write your answer in roster form. Okay, so that means we're looking at the months that do not have exactly 31 days. And so the complement would be February, April, June, September, and November. Okay, lesson check. You need to have try this before you come to class. Make sure you have all 8 questions answered so that we can go over it together as a class.